In this segment, we will work a few examples. Okay, in this particular case, we have a car traveling at a rate of 10 meters per second, accelerates to 90 meters per second in 12 seconds. Calculate the magnitude of its acceleration. Now, the plus 10 meters per second is a velocity. The plus 90 meters per second is another velocity. 12 seconds, that's a time. And we are asked to find an acceleration. The magnitude is, they care about how big it is. Now, we have both of them are plus velocities. That's telling us of the direction. Now, if we try to use symbols for these quantities, this is the first velocity, this is the second velocity. So the first one would be my initial velocity. And in that case, that would be plus 10 meters per second. My final velocity is the plus 90 meters per second. Now, my 12 seconds is time. So my acceleration is going to be Vf minus Vi over time, which is in this case 90 meters per second minus 10 meters per second over 12 seconds. So in this case, that's going to be 80 meters per second over 12 seconds. Okay, 80 over 12, how much is that? Now, that's 40 over 6, and that's 20 over 3. So 6.67 meters per second squared, I believe. I'll check it here on the side just to make sure. Okay, I got it right. Okay, that's our acceleration. Okay, we have another example. We have a car moving at 40 meters per second, slows down to plus 10 meters per second in 3 seconds. What's the acceleration? Again, by the way, when they ask you for magnitude, they don't care about the direction. The direction is going to be the sign, but here they don't care about the direction. So let's do the work. My Vi is plus 40. My Vf is plus 10. My T is 3 seconds. So my acceleration is Vf minus Vi over time. In this case, that's going to be 10 meters per second minus 40 meters per second over 3 seconds. So that's going to be minus 30 over 3, so minus 10 meters per second squared. Now, that's my acceleration minus 10 meters per second squared. The magnitude of the acceleration is 10 meters per second squared. Okay, let's work another example. We have a car traveling at 40 meters per second. It slows down to 10 meters per second in 3 seconds. The question, how far did the car move in the 3 seconds? Okay, so what do we have here? The beginning velocity is 40 meters per second. The final velocity is 10 meters per second. The time It's 3.0 seconds. Okay, and we are asked to find how far did it move. We are asked to find essentially the displacement. Now, how are we going to find that? It is easy if we have constant acceleration, and in this question we just worked the acceleration. It is assuming a constant acceleration. The wording could have been a little bit better telling us that. I apologize for that. But assume, let's add here, assume constant acceleration. Okay, so what that means, one of the equations that we have for displacement, okay, let's see, just to make sure that we remember it. Okay, that's one of the equations is this. Displacement is average velocity times time. Average velocity times time. The I there was wrong, I didn't notice it till now. I think we were at this slide. No. Okay. So in this case, so to find the displacement, average velocity times time. And for constant acceleration, the average velocity is the initial velocity plus the final velocity over 2, which in this case is going to be equal to 40 meters per second plus 10 meters per second over 2. So 40 plus 10, 50 over 2, 25 meters per second. So then my displacement is 25 meters per second times 3 seconds. That gives me 75 meters. Seconds cancel out. Okay, let's go next. So in this case, we have a car traveling at 40 meters per second and slammed to the, on the brakes and came to a full stop 120 meters later. We are asked to find the acceleration. So what are we given here? We are given the beginning velocity. Vi is plus 40 meters per second. We are given the final velocity. Came to a full stop. That's the final velocity, 0. And we are given the displacement, 120 meters. And we are asked to find the acceleration. No time is given. Now, let's remember that's 53. If you recall from these equations, okay, we can look at it here or here, either way, we have Vf squared minus Vi squared is equal to AD. That's an equation that does not have time. So we are going to write that equation here. Vf squared minus Vi squared is equal to AD. Now, we know Vf, 0, minus plus 40 meter per second squared, and that's equal to twice A, what we are trying to find, times 120 meters. So if I calculate this, that gives me A is minus 40 squared, that's 1,600 meters squared per second squared, over 2 times 120, that's 240 meters. Okay, one of the meters cancel, and I have 1600 over 240, or 160 over 24. Let me make sure. 160 over 24, that makes it 80 over 12, minus 80 over 12 meters per second squared, and then that makes it 40 over 6 and 20 over 3, so it is minus 6.67 meters per second squared. The fact that I found the same acceleration as before made me worry that I have something wrong. Okay.